Welcome to the Rotec Rally Flight Instruction System. This portion of your Rally Pilot Training course will consist of actual flight instruction. At this point in your training, you should have already attended the ground school portion of the Rally Pilot Training course, and you should have a good understanding of basic aerodynamics, flight regulations, meteorology, and navigation. These subjects will not be reviewed in the information that follows. If you still have questions about these subjects, or if you have not attended the ground school portion of the course, stop the tape here and ask your instructor to help you before going on. If you have mastered these subjects, we can continue. This phase of your Rally Pilot Training course will teach you how to perform a thorough pre-flight inspection, proper use of safety equipment, use of control systems, instruments, emergency procedures, flying in turbulence, and actual hands-on instruction in the flight and control of the Rotec Rally ultralight aircraft. Let's start with a pre-flight inspection. The purpose of a pre-flight is to check for any damage, wear, missing parts, or other signs that the Rally may not be safe to fly. Keep in mind that the pre-flight inspection is probably the most important part of a safe flight. Every year, a surprisingly large number of pilots make very short flights in partially disassembled airplanes because they fail to perform an effective pre-flight. The key to an effective pre-flight is to inspect every tube, cable, fastener, and attachment on the Rally. Everything is exposed and easy to see. All you have to do is look. Always check everything in the same order each time. Never fly your Rally if any part is damaged or questionable in any way. If you find anything wrong or even questionable, stop your inspection right there and fix it. Then start the inspection over from the beginning. Before you start your close-up inspection, take a good look at the Rally from 10 or 15 feet away. Look at the overall rigging and symmetry of the ship. Does everything look straight and square? A twisted wing or bent tube will be less obvious up close, so look for these things now. Always start your close-up inspection from the nose of the Rally and work your way around the airframe in a counterclockwise direction. Start by proof-loading the rudder control system. Simply pull firmly on the pedals in each direction. Inspect the control lines and attachments. Make sure the ends are bound and the connectors are safetied. Kneel down and look at the bottom of the pedal board and axle. Check the airspeed indicator and mount for proper position. Make sure all speeds between stall and redline are visible. The red disc must move freely and the tube must be straight up in flight. Look at the lower nose wires where they attach to the root tube. The clevis pin, like every other clevis pin on the Rally, should be secured with a safety ring and a safety pin. Inspect the upper nose wire at the top of the root tube and the top of the king post. Check the control pulley on the upper nose wire for proper operation and freedom of movement. Check that the pip pins holding the king post in place have safety washers. Inspect the bolt holding the king post lever channel to the root tube bracket. Check the wing nuts and safety pins securing the front cockpit tubes to the root tube. Check the fuel level. Never fly with less than a full tank. Be sure the gas cap is tight. Now look at the Spoileron control lines attached to the top of the control stick. Proof-load them by pulling firmly on each line. Move the control stick to full travel in each direction. Check to see that it moves freely and that the elevator moves in the right direction. Check the lower control line attach point. Inspect the electrical connections at the control stick. Check the plastic washers and pip pin at the control stick pivot point. Inspect the lower cockpit tube attach points, landing gear bungee, tire, wheel, and lower flying wire attach point. Check the upper attach point for the triangle bar. The wing nuts must have safety pins. Check the pull start handle and return limiting knot. Check the fasteners securing the top of the rear fuselage tubes. Inspect the left diagonal strut, its attaching hardware, and the leading edge bracket of the root tube. Now, start along the leading edge of the left wing. Run your hand along the tube to feel for dents or nicks. Check each flying wire attachment for damaged cables, thimbles, or nicopress sleeves. Look at each compression strut to see if it is straight. The pulleys attached to the outboard wing wires must be checked for binding. When you reach the wingtip, check the end plate attachment points and the short strut supporting the last rib. As you start down the trailing edge, run your hand along the spar, again checking for dents or other damage. Check each rib to see that it is pushed in all of the way. Check each cable for damaged thimbles or sleeves, kinks, or any sign of damage. Sight along each cable to the king post or lower attach bracket to be sure that thimble is not twisted at the end. When you reach the tail boom, check the pip pin to see that it is pushed in all the way and that it has at least one flat washer between the ball and the bracket. All of the ribs between the tail booms must be safety wired to keep them from backing out into the prop. Check the prop for nicks or cracks. Turn it to check the bearings and clutch for roughness or noise. Check bearing mounts for looseness or cracks. Look at the slippage mark between the clutch and drive shaft. Inspect the bearings and bolts under the mounting base. Check the anti-torque connections. Check the drive belt for proper tension. Look at the muffler mount and check the safety wires on the mounting springs. Inspect the engine mount and welds. Check the fuel lines and clamps. Look under the horizontal stabilizer to check the mounting bolts. Be sure all of the nylock nuts on the rally have at least 3 threads showing past the nylon. Test the upper and lower tail wires for tension. Be certain they cannot contact the prop. Check the elevator control lines, trim bungee, and elevator hinges. Check the rudder hinges and control line attachment. Check that the rudder moves freely. Inspect the opposite side of the elevator and stabilizer. Push on the tail to see if the tail wheel is secure and moving properly. Check the right tail boom pip pins and safety washers. Inspect the control line pulley attached to the first set of wing wires and inspect the trailing edge of the right wing the same as you inspected the left wing. Remember to check the tip strut when you check the wingtip. Now inspect the right leading edge, wires, and attach points. Don't forget to look at each compression strut. These must be absolutely straight. When you get back to the cockpit, check the lower flying wire attach point, tire, wheel, and landing gear bungee. Inspect all right side fuselage tubes and mounting points. Check all control surfaces again for full travel and movement in the proper direction. It is possible to connect them backwards, so check carefully. Test the kill switch for detents and proper operation. Twist the throttle and check for smoothness. Make certain that no objects are lying on top of the wing. After you have completed your pre-flight inspection, start the engine and let it warm up for a few minutes. Always check to see if you are in an area where engine starting is permitted before you start up. Check to see that your prop danger zone and prop blast zone are clear, and shout "clear prop" in a loud, clear voice before starting the engine. When the engine is warm, check to see that it will maintain a smooth, steady idle with the throttle released completely. If the engine does not idle properly, fix it now. Final approach is no time to be performing a wrist action tune-up on an engine that won't idle. If the engine idles smoothly without touching the twist grip, switch the engine off and check to see that it will restart on a single pull. If it won't restart on one pull now, on the ground, it certainly won't restart in flight. And if it didn't start on one pull, find out why and fix it. Now that we know the airframe and engine are ready for flight, let's review the proper tie-down points for the rally. The best tie-down points are the outer wing wire attach points on the lower surface of the wing and the U-shaped tube that supports the horizontal stabilizer. Yes, we know this makes 5 tie-down points. By tying the leading and trailing edges of the wings, we reduce loads that can twist the wing tubes and fittings. Always use all 5 tie-down points. Now, the rally won't leave without you while we check out your safety equipment. Never fly without a helmet. Even though the rally cockpit has been designed for maximum pilot protection, if you contact one of those stout tubes with your bare head in the rough landing or crash, you could receive a serious or even fatal injury. When you're shopping for an ultralight safety helmet, look for a design that is comfortable, lightweight, and offers good visibility. Always look for this Department of Transportation decal on any new helmet. It is your assurance that the helmet has been tested and meets certain minimum government standards for impact protection. A final word about helmet selection. Buy the most expensive model that you can afford. Extra quality means a higher price tag, but safety equipment is no place to try to save $5 or $10. Never fly without eye protection. Flight control is about 90% visual. Any eye injury or even dust in your eyes can make controlling your rally almost impossible. Motorcycle goggles, helmet visors, or face shields, ski goggles, or full coverage safety helmets all work well. Sunglasses do not work well and are not acceptable without additional protection. Do not take chances with a loss of vision in flight. It is an experience you can live without. Now, let's take a look at emergency parachutes. These emergency recovery systems have proven themselves as last resort life-saving systems. The Rally has a safety record that is the envy of many aircraft manufacturers, both ultralight and conventional. This does not mean, however, that an accident cannot happen. Safety in flying any type of aircraft comes primarily from pilot judgment, caution, and skill. If an error, poor judgment, or simple bad luck should cause you to become one of those extremely few rally pilots who experiences a complete loss of control due to equipment failure, extreme turbulence, or mid-air collision, these life-saving devices can bring you down in such a manner that you could probably walk away. Without a parachute, this type of extremely unlikely in-flight catastrophe spells certain death. We strongly urge that you buy and carry an emergency parachute at all times. Additional critical safety equipment is found on the Rally airframe. A seat belt is standard equipment on every Rally. Use it. It may seem ridiculous to explain that the seat belt is there to keep you from falling out of the airplane, but people have actually fallen out of airplanes because they did not fasten the seat belt. Let's make sure this never happens in a Rally. Buckle the belt. When you snap the belt, make sure the release button is on top. It is very difficult to release a tight seat belt with the release turned to the inside. Before your first training flights in the Rally 3, Rally 2B, or the Sport, be certain the training wheels are securely taped in place. It only takes a few wraps of fiberglass tape to hold these safety wheels in place. You will think the time was well spent if you touch them to the ground while learning to handle the pitch control during fast taxi or your first few landings. We realize that some of you may feel embarrassed by training wheels, but they will keep the Rally from nosing over if you make a small error in the pitch control. Your instructor will also use an intercom of some sort to allow you to talk to one another in flight. This may be an electronic or an acoustical unit. Ask your instructor if you have any questions about the operation of the unit he is using. You both need to be able to communicate clearly in flight. The key to learning to fly the Rally is to listen and follow all instructions given to you by your flight instructor. Now, let's move on to the Rally control systems. All Rallies have a center-mounted overhead control stick which can be operated with either hand. Before you start your first lesson in the Rally 3 trainer, try sitting in each seat and moving the control stick from each side of the cockpit. Most Rally flight instructors have mastered flying the Rally 3 with either hand and will encourage you to fly from the side that will allow you to be most comfortable. When you have selected the seat and hand position that will be most natural to you, adjust the seat forward or back to give an easy reach to the rudder pedals. Make sure you can reach full pedal stroke in each direction. Primary controls on all Rallies are the overhead control stick, rudder pedals, and throttle. Secondary controls are the kill switch, pull start, choke, and fuel shutoff. Moving the control stick forward pulls the elevator down and will cause the nose to move down in flight. Moving the stick rearward moves the elevator up, raising the nose. Use this and all other flight controls smoothly. Movement should be slow and deliberate. Rapid seesaw motions with the controls will usually produce no response from the airplane, or could produce the rapid up and down motion known as a pilot-induced oscillation and resulting loss of control. Moving the control stick from side to side actuates the spoilerons on top of each wing. When you move the stick to the right, the spoileron on the right wing will rise, reducing lift on the right wing and allowing it to sink relative to the left wing. This will bank the rally and is used in coordination with rudder control to turn. The rudder pedals are linked to the rudder. Push the right pedal and the rudder will move to the right, turning the rally to the right. The throttle is controlled by the twist grip on the control stick. Twist the grip clockwise to increase power. Because the throttle twist grip is on the control stick, you must always be careful not to move the stick when you only want to change power. You must also avoid twisting the grip when you only wanted to move the stick. After your first few minutes of flight, this will all seem very natural, but remember to be careful during those first few minutes. Directly above the twist grip is the engine kill switch. This switch must be in the center position for the engine to run. Push to either side to stop. Above your head, you will find the engine starter pull handle. Pull this handle down and forward to start the engine. This handle is located so it can be reached from the seat, allowing the engine to be stopped and restarted in flight. Near the pull start handle, you will find the red remote choke control for cold engine starts. Forward of the pull start handle on the bottom of the fuel tank, you will find the two small red fuel shutoff levers. Both of these controls should be turned straight down before starting the engine and turned 90 degrees to prevent fuel flow when the engine is stopped. All rallies are shipped from the factory with the Hall Brothers airspeed indicator. The small red plastic disc inside of the clear tube rises higher as your airspeed increases and drops lower as you reduce speed. The calibrations on the tube represent speeds in miles per hour. The Hall airspeed indicator should be mounted on one of the front cockpit tubes in a position where you can clearly read the numbers. If a pod is installed on your rally, locate the airspeed indicator at least 1 foot above the top of the pod to avoid inaccurate readings. Even when the Hall airspeed indicator is installed properly, it can read as much as 5 miles per hour faster than your actual airspeed if you have the throttle wide open. Watch carefully for this kind of error at low speeds and high power settings. Check that the small inlet at the bottom of the airspeed indicator is pointed directly forward and that the main body will be vertical in flight. If the instrument is not vertical, or if the inlet is not facing forward, the airspeed reading will not be correct. Check that the mounting clamp does not cover any airspeed marking in the range you will be using. All speeds between stall and VNE must be clearly visible. For the Rally 3, this means you must be able to read from 20 miles per hour, which is stall, to 50 miles per hour, which is VNE or maximum safe speed. Never exceed the maximum safe speed at any time. Your dual instruction training in the Rally 3 will begin with slow taxi. Note how your instructor coordinates the rudder with the throttle to get quick, precise steering control. Watch the airspeed indicator. It takes careful control to keep speed under 10 miles per hour. Also notice how the instructor keeps the control stick back slightly to keep the tail wheel firmly on the ground. After a couple of minutes practice at this, your instructor will show you how to do S-turns. Notice that he applies opposite rudder well before the point where he wants to change direction. Next, you will get a demonstration of proper takeoff technique. After the rally has been lined up with the wind, make a reference point directly in front of you, as far away as possible. Watch this reference point as the rally takes off. Your instructor will apply full power. Push the stick forward slightly to raise the tail at about 15 miles per hour. and then raise the nose smoothly to lift off as the red disc passes through 25 miles per hour. Once the wheels leave the ground, the rally will accelerate rapidly. Notice that your instructor is flying directly towards the reference point you picked before takeoff. Always select a ground reference point before takeoff and fly directly toward it on your initial climb. This will help you maintain alignment with the wind while you take off and climb. Watch how the instructor uses the control stick to regulate airspeed by raising or lowering the nose slightly while holding the throttle wide open. When you have reached a safe altitude, your instructor will level out and reduce power to set up level cruise flight at 35 miles per hour. Watch how he still raises or lowers the nose to control airspeed and adjust the throttle slightly to hold a steady altitude. Remember that the control stick adjusts airspeed and the throttle controls altitude. Add power to go up, reduce power to go down. Raise the nose to go slower, lower the nose to go faster. After you have practiced level flight control for a minute or two, your instructor will demonstrate a turn. Notice that he will use the rudder pedals to start the turn and then pull back slightly on the stick to keep the nose up. You may also see or hear that the throttle was opened slightly when the rally entered the turn. The airplane will gain speed as you turn if you do not raise the nose. You will lose altitude in the turn if you do not add a bit of power. For the experienced pilots of conventional aircraft in the audience, this is a good time to point out that turns should be made with the rudder as the primary control in the rally. Like most ultralights, the rally turns much better with rudder than it will with spoilerons, which are strictly secondary controls. They are intended to supplement the roll rate achieved by the rudder. When you try your first turn, remember to keep the nose up to maintain a steady 35 miles per hour airspeed and add a bit of power to maintain your altitude. Now your instructor will demonstrate descent. Remember that power is your altitude control. Watch as the instructor reduces the power and lowers the nose to maintain 35 miles per hour in the descent. When you try it, remember to lower the nose slightly as you reduce power to maintain 35 miles per hour. After you have made a few short descents, your instructor will demonstrate power on stalls. Notice that he holds the same steady power setting as he gradually raises the nose way above the horizon. Watch the airspeed indicator as the nose goes up and the airspeed goes down. As the rally slows down to stall speed, you will feel the airframe shake and feel the wind on your body reduce. When the rally finally stalls and the nose drops, you will hear your instructor open the throttle to full power. At the same time, you will see him move the control stick to a neutral position to let the rally build up speed again. Watch the airspeed indicator. Very quickly, the rally will come back to 30 miles per hour, and your instructor will start to raise the nose. Notice that he does not reduce the power setting until the rally is back in level flight. When you try your stalls, remember to add full power at the moment of stall break, and don't forget to move the elevator back to neutral position to let the rally get back to flying speed. If you feel the wings start to drop at a point in the stall sequence, use the rudder to pick it up. Simply push on the rudder pedal nearest the high wing. You can think of this as stepping on the high wing to push it down. Do not try to pick up a stalled wing with the spoilers. As soon as you see 30 miles per hour on the airspeed indicator, start to raise the nose smoothly and reduce power after you are back in level flight. Next, your instructor will set up a landing approach to the airfield. Notice that he turns the rally to land directly into the wind, even if this means he will be landing at an angle to the runway. Always land directly into the wind. Watch ground objects as they pass under you. Notice that your instructor has turned the rally so that everything passing under you travels in a straight line from the nose of the rally to the tail. This tells you that you have eliminated all wind drift. When you set up your first landings, make sure that ground objects are not passing under you diagonally. If they are, you will touch down crosswinds and sideways. This could lead to a ground loop and serious damage to the rally. Your instructor has picked a landing spot in the first 1/3 of the length of the runway. Search this area for the one spot that seems to hold still while it grows larger. This will be your touchdown point. When you are about 3 to 4 feet above the ground, you will feel your instructor raise the nose slightly to level flight and then reduce the power smoothly to idle. As the speed bleeds off, the rally will settle gently to the ground on its main wheels only at first. Then the tail wheel will drop as the rally continues to slow down. Do not pull back on the stick until your speed drops below 15 miles per hour. This will prevent you from ballooning back into the air. After discussing this flight and answering any questions you might have, your instructor will be taking you out again to try your first takeoff and landings. Only after you have mastered these basic flying skills with an instructor in the two-place Rally 3 flight trainer will you go on to solo instruction in the Rally 2B. Stop the tape here and discuss these maneuvers with your instructor before your first dual instruction session. Oh, and good flying. Before you begin your solo instruction in the Rally 2B, you must perform a thorough pre-flight inspection. Refer back to the segment on pre-flight inspection near the beginning of this tape if you have any questions about the proper inspection procedure. When you have completed the inspection, including the checks for engine idle and restart, climb into the pilot seat, grip the control stick, and place your feet on the rudder pedals. Now, adjust the seat forward or back until the rudder pedals are in easy, comfortable reach, and you can move the control stick back to full-up elevator without the twist grip striking your chest. When you have found a comfortable seating position that allows free movement of all controls, ask your instructor to check the balance of the rally with you and a full tank of fuel on board. Make certain that the center of gravity is still within the range for which this rally has been trimmed for hands-off level flight. If the balance has shifted beyond the limits for the current trim adjustment, do not fly until the trim has been reset. With the rally full of fuel and properly trimmed, climb back into the pilot seat and check the position of the airspeed indicator. As before, the clear plastic tube must be straight up in level flight attitude, and the inlet port at the bottom must face straight forward or the readings will not be accurate. When you check the location of the mounting strap, make sure that you can read all of the speeds between 19 miles per hour and 50 miles per hour. The power on stall speed of the Rally 2B is only 19 miles per hour, and the red line or never exceed speed is 50 miles per hour. Be certain that you can read all of the speeds within this range and never allow the Rally 2B to go faster than 50 miles per hour. If the winds are calm, you are now ready to start with slow taxi practice. Gradually add power until the rally begins to roll. This power level is called breakaway thrust and is usually more power than you will need to maintain a slow taxi speed. Add and reduce power as necessary to keep the rally rolling, but don't let your speed go over 10 miles per hour on the Hall airspeed indicator. All slow taxi practice should be at 10 miles per hour or less. To keep the tail from lifting and the blast of air from the propeller, you will have to keep the control stick pulled back a bit. This will also help to keep the rally from tipping over any ruts or holes in your practice field. If you taxi too fast, or if you don't maintain some tail-down force, the rally will tip forward on ruts or holes and could strike the forward cockpit tubes against the ground. Training wheels will prevent these accidents during training, but it is still important to practice the skills needed for later flying without the safety wheels. If you do get caught in a rut or hole, do not try to power your way out. Simply turn off the engine, get out of the rally, and pull the plane to smoother ground. Remember to refasten your safety belt when you get back in. As you begin to roll forward, you will be able to control your direction with the rudder pedals. Push the right pedal to turn right. At these very slow speeds, the rudder will not be effective for turning without the prop blast to help it out. Therefore, the amount of pedal needed to turn will increase as power is reduced. You will need less rudder if you increase the power setting, but be careful not to let your speed build up. After a few minutes of practice, you will have the feel of rudder input and power setting needed to maintain your speed and turn rate. Now, you're ready to try some S-turns. Practice until you can make smooth arcs to each side of your path with complete control of direction and speed. Remember to keep your speed below 10 miles per hour. In this early phase of your training, you will be practicing in zero wind. The light wing loading of the rally airplanes would make it impossible to learn the relationship between control input and response if you tried to learn in even light winds. When you have learned the basic skills, you will begin to fly in stronger winds, eventually working up to winds as strong as 15 miles per hour. As you start to practice in light winds, you will need to keep the wings level when they are upset by gusts. When you are taxiing in any wind at all, you must taxi straight into the wind whenever possible. When you have to taxi crosswind, raise the spoiler on the upwind wing to reduce the chance of the wind lifting it. If a wing does start to rise while you are taxiing, raise the spoiler on that wing by moving the control stick as far as it will go toward the wing. Be careful not to twist the throttle open or pitch the nose down when you move the stick. At the same time, you should use the rudder pedals to turn the nose toward the high wing and then reduce the power to idle. If you cut power first, you will lose rudder control. If you do not cut power after you turn the nose into the wind, you may take off due to airspeed being increased by the sudden headwind. Let your speed come down and let the rally settle down before you turn back to your original course. Fast taxi is done with the tail up and the rally resting on its main wheels only. At about 15 miles per hour, the rally will lift its tail if you release the back pressure on the control stick and push forward very slightly. Be careful not to let the nose touch the ground. Fast taxi is only a transition from slow taxi to flight. Your rally is very susceptible to wind or gusts when you taxi with the tail up. You should not use tail up taxiing for normal ground movement. Takeoff is a simple transition from taxi to flight. Always take off directly into the wind. When you are lined up with the wind, twist the throttle wide open and apply a slight forward pressure to the stick. Keep your line of sight well out in front of the plane. When the tail wheel lifts off, hold the front tubes 8 inches to 10 inches off of the ground with the control stick while your speed builds up. Very quickly, you will have 30 miles per hour of airspeed, and you can pull back slightly on the stick, and your rally will be airborne. As the rally leaves the ground, you may notice that the nose is swinging off to the right. This is caused by engine torque. Apply slight pressure on the left rudder pedal if you are drifting to the right. While holding the throttle wide open, use the control stick to maintain 35 miles per hour on the airspeed indicator. If you push forward slightly, the airspeed will increase. If you pull back, you will slow down. Continue to climb at 35 miles per hour until you are 200 feet or more above the ground before you start your first turn. Never turn at low altitude when you can avoid it. As you climb, you may encounter bumps and turbulence in the air that will try to raise one wing above the other. Due to their light weight, ultralights are very sensitive to these bumps, even on calm days. In taxi training, you used your spoilerons to level the wings when gusts lifted them. In flight, you will find that the rudder is much more effective at leveling the wings. Simply push on the rudder pedal closest to the high wing, and the dihedral of the wing will make the rally bank back to level attitude. You can think of this as stepping on the high wing to bring it back down. Pilots of conventional aircraft, please note that the rally will turn and bank much better on rudder control alone than any conventional design. When you want to level the wings after a bump or when you want to turn, remember that the rudder is your primary control and the spoilerons are supplemental. You will not get very fast turn response with the spoilerons alone. Now that you have reached 200 feet, you can start your first turn. If you have any doubt about being 200 feet up, Climb a little higher to be sure. You will start your turn by pushing gently on the rudder pedal in the direction you wish to turn. Left pedal will turn you to the left. As you push on the left rudder pedal, the rally will turn to the left and begin to bank to the left. As the rally starts its left turn, you will notice that you are beginning to lose altitude and pick up airspeed. The G-force of the turn has increased the load that the wings must support. To support this extra load, you will have to increase your lift, or you will continue to lose altitude. Pull back slightly on the control stick until your airspeed is steady at 35 miles per hour. Since you are still climbing in the traffic pattern, you will now be climbing at full power in a left turn. When you have reached a bank angle of 10 or 15 degrees, reduce the pressure on the rudder pedal to stop the bank from increasing further. You will have to hold slight pressure on the pedal and the stick to maintain a stable turn. As you approach the direction you wish to fly for your crosswind leg, release the pressure on the left pedal or apply very slight pressure to the right pedal to stop the turn. At this time, you will have to reduce the back pressure on the control stick to maintain 35 miles per hour airspeed. You are now continuing to climb in the crosswind leg of the traffic pattern. You can use the same technique to make a 45-degree turn and exit the traffic pattern. The actual direction and altitude of these turns will vary with every flying site. Your instructor will show you the correct traffic pattern for your training field. Now that you are out of the traffic pattern, climb to your chosen cruise altitude and level out by releasing back pressure on the stick and reducing power to about half. Remember that the control stick is your speed control and the throttle is your altitude control. Check to see if you are in level flight attitude by looking at the wingtip compression struts on each wing. In level flight, these should be parallel with the horizon. If you cannot hold these level with the horizon while you maintain 35 miles per hour, raise or lower your power setting until they flatten out at 35 miles per hour. You are now in level flight and maintaining altitude. If you add power while holding 35 miles per hour, you will climb. If you reduce power and hold 35 miles per hour, you will descend. When you have stabilized your speed and altitude, practice a few gentle left and right turns. When you enter a turn at cruise power, you may have to add a bit of power after you raise the nose, or the rally will lose a little altitude. Make a few turns holding a steady 35 miles per hour, but without adding any throttle above cruise power level, and see how much altitude you lose. This is caused by the increase in wing loading created in a turn. Now that you have a good feel for coordination of rudder, elevator, and power for turns, try adding spoileron as you enter your next turn. Notice how the roll rate increases and the elevator and power inputs increase slightly. This is due to the reduction of lift caused by the spoileron combined with the increased load caused by centrifugal force. This reduction in lift can actually cause the rally to sink slowly if you move the control stick back and forth rapidly to the left and right without holding one control setting long enough for the wing to roll. Next, you should practice controlled descent. Reduce power a bit below level cruise setting and lower the nose to maintain 35 miles per hour airspeed. If you want to descend faster, reduce the power more and lower the nose further to maintain your speed. Remember, reduce power to descend and use the control stick to hold your speed. Increase power to reduce your descent rate. Descend about 100 feet, then add power. Climb back up and descend 100 feet again until you can control descent rate and speed easily. Now you can try a stall. A stall is a very gentle and easy maneuver in the rally. There will be nothing frightening about it. Resume level flight at cruise power and 35 miles per hour. To try your first stall, simply raise the nose gently while holding a constant power setting. As the nose rises, the speed will drop rapidly. Hold your power setting and use the rudder to keep the wings level if necessary. Never chop the power abruptly in a nose-high attitude. Otherwise, a whip stall will occur, causing undue stress to the airframe. As airspeed drops down close to 19 miles per hour, the rally will begin to shake, and the control stick will begin to feel soft or sloppy. As you get close to stall, the elevator will no longer raise the nose higher when you pull the stick back more. When speed drops to 19 miles per hour, the rally will stall. This simply means the lift of the wing is now less than the weight of the rally, and the plane will begin to sink. Due to the design of the rally wing, the nose will begin to drop as the rally stalls. As the nose starts to drop, add full power and move the elevator to the neutral position. Now the rally will begin to accelerate rapidly. You can raise the nose and resume level flight as soon as the airspeed comes up to 30 miles per hour. With some practice, this entire routine can be done with a loss of less than 25 feet of altitude. After a few more minutes of practicing these maneuvers, return to the airfield. Descend to pattern altitude and return to the pattern at a 45-degree angle to the downwind leg and check the windsock and streamers to be certain that your landing approach will be directly into the wind. Always look carefully for other aircraft before making any turns or entering the traffic pattern. Make your turn to base leg when your intended touchdown point is 45 degrees behind you. As you turn to final approach, check the wind again. If the wind is blowing at an angle to the runway, land diagonally to the runway if necessary, but always land directly into the wind. Hold your approach speed at 35 miles per hour and check your path for wind drift angle. If ground objects are approaching at an angle, you are not landing directly into the wind. Turn the nose until ground objects are moving directly under the rally from nose to tail. You can also check drift angle with a yaw string. Attach a piece of yarn to a flying wire near the cockpit and note the direction that it blows back. If the yarn is not blowing straight back, you are not landing directly into the wind. When you have eliminated your wind drift angle, simply continue your descent at 35 miles per hour to a height of 3 or 4 feet above the runway, then add slight power if necessary, and hold level flight at 35 miles per hour while you concentrate on holding alignment with the wind on your approach. About halfway down the runway, apply full power and climb back up into the pattern. Repeat the traffic pattern completely and make 2 more of these low passes the length of the runway before you set up your landing approach. Do not attempt a landing until you feel comfortable with your low passes. Remember to watch your fuel supply closely if extra passes have to be made. When you make your last turn from base leg to final, reduce power and lower the nose to achieve a steady descent at 35 miles per hour. Concentrate for a moment on your intended touchdown point. Add or reduce power while holding 35 miles per hour with the control stick until the point where you want to land appears to be growing but not moving in your field of vision. If your touchdown point is rising in your sight picture, you are descending too fast and will land short. Add power gradually until the landing point stops rising. If the point is falling in your field of vision, you are too high. Reduce power and maintain 35 miles per hour with the control stick to descend faster. If the power is down to idle, speed is 35 miles per hour, and your touchdown point is still falling, you cannot make your touchdown point safely. Smoothly open the throttle to full power, climb to 100 feet, and repeat the pattern. When in doubt, go around, fuel permitting. When you have a stable sight picture of your intended touchdown point at an approach speed of 35 miles per hour, simply fly down to an altitude of 3 or 4 feet above the runway again. This time, level off as before, but gradually reduce the power while you hold the rally in a level flight attitude until the wheels touch. A very slight forward force on the stick may be required as power is reduced. Let the rally touch down in a level flight attitude. Do not attempt to flare. Touch down on the main wheels only and let the tail wheel drop on its own as the speed falls off. Your instructor will have marked a go-around point at about half of the length of the runway. If your wheels have not touched the ground by the time you reach this mark, smoothly add full power, climb out, and repeat the pattern and approach. Do not attempt to land beyond the marked go-around point. When you have safely completed your landing, taxi off of the active runway immediately. Oh, and congratulations, you are now a rally pilot. Now that our intrepid rally pilot has returned from that solo flight, let's take a look at some of the emergencies that can arise in flight and the procedures to deal with them. Unquestionably, the in-flight emergency you will be most likely to experience is an engine failure. Any engine can stop at any time, and all pilots must continually be alert for emergency landing facilities if this should occur. No matter what the circumstances may be when the engine stops, the first thing the pilot must do is establish a stable glide. In nearly all normal flight, this means lower the nose now. When you have the rally gliding at a steady 35 miles per hour, pick the emergency field you want to land on, the direction of the best landing approach, and start gliding in that direction. Higher airspeeds may be used, but remember, your descent rate increases proportionately with increased airspeed in an engine-off situation. Once you have your emergency field selected and have started toward it, you can try to restart the engine if you want to, but don't expect the engine to start. Whatever made it stop will usually keep it from starting until you can work on it on the ground. If you are below 200 feet, do not attempt to restart. Concentrate on a safe landing. Before you pull the rope, check to make sure the ignition switch is on and that fuel is visible in the fuel lines. If these check out, try 1 or 2 pulls. If it won't start in 2 pulls, forget the engine and focus all of your attention on a successful landing. Remember to line up directly into the wind and make your approach a little higher than normal to allow for your higher sink rate. Potentially more serious than an engine failure in cruise flight would be an engine failure on takeoff or climb out. The procedure is exactly the same as you would follow if the engine should fail in level flight. Get the nose down immediately and pick the spot where you want to land. There are 2 major differences in this type of engine failure that can cause serious problems. First, since the nose will be fairly high on takeoff, you will have to push it down hard to avoid a stall. Second, for some reason, most pilots find it almost irresistible to attempt to turn back and make a downwind landing on the runway they just left. Don't do it. You will never make it. You simply do not have enough altitude on takeoff to make a 270-degree turn and set up a controlled approach to a downwind landing. The only correct procedure for a forced landing on takeoff is to put the nose down immediately. Keep the wings level with the rudder and pick the best landing spot that is available straight ahead. This may mean landing on a very poor spot, but a controlled landing in a bad place is always better than a crash in a good location. Proper maintenance can almost eliminate engine failures, but it is only common sense to always fly as though you expect the engine to stop at any moment. Keep an emergency landing site within glide range at all times. Another type of emergency that is even more unlikely is control system failure. Proper maintenance should eliminate these failures entirely, but they can still happen occasionally. The Rally has a very safe and well-proven control system. However, if a failure should occur, the Rally has been designed with enough basic stability that the problem should not be catastrophic. Let's look at each control in ascending order of urgency. Of the 3 major flight control systems, the Spoilerons are the least critical. The Rally spoilers are designed to spring load closed, and in the event of a failure of both the control cable and the closing bungee, the spoiler will close from air pressure. If a spoiler control line fails in flight, simply fly with the rudder until you can land. The next most troublesome failure would be the rudder linkage. In the event of loss of rudder control, you can still make slow, shallow bank turns with the spoilerons. You will not have as much control as you do with the rudder, and response will be slower, but you should be able to bring the rally down safely. The most difficult flight control to fly without is the elevator. In the rally construction manual, you were or will be told how to adjust the horizontal stabilizer angle of attack to trim the rally for hands-off level flight at cruise power. If you have trimmed your rally properly, you can control pitch attitude and climb or descent by making small, gradual adjustments in power setting. If you increase power, you will climb. If you reduce power, you will descend. Again, if you have properly trimmed your rally, you can bring it down safely with the power control. If you have failed to adjust the trim on your aircraft, we hope you did not also fail to take the warning about an emergency parachute. If the rally is not trimmed for level cruise flight, hands off, it will not be controllable in the unlikely event of an elevator control system failure. The other area of serious flight emergency offers only one option. In the very improbable event of an in-flight airframe failure, the only practical course of action is to deploy your parachute now. Whether the failure is caused by pilot error, extreme turbulence, poor maintenance, or mid-air collision, the only chance is a parachute. These emergency systems will bring you down to a hard landing about equal to stepping out of a second-story window. They should never be used unless you are in real trouble. But in the event of airframe failure, it is critical that you throw the chute at once. Here's how it is done. First, stop the engine. Second, remove the deployment bag from the protective cover of the chest pack, using both hands to cradle the stowed lines. Third, if the aircraft is spinning, and it probably will be, throw the chute with both hands as hard as you can throw in the direction of the spin. Throw through the largest opening in the cables that you can see. This will normally be between the front cockpit tubes and the first flying wire on the side that you are spinning toward. Look before you throw. Structural damage may have closed that opening, and you may need to throw in a different direction. If the chute doesn't open within 2 seconds, grab the bridle and yank hard. If it still doesn't open, reel the whole thing in and throw it again. One last subject we should cover before you grab your instructor and run to the rally is turbulence. As we mentioned earlier, ultralights are very sensitive to turbulence. Even on a very calm day, you will always experience some bumps and rough spots. Don't let turbulence frighten you. The rally has been designed to safely take quite a bit of punishment from rough air. Once you have reached a safe altitude, 100 feet or more, if you encounter small bumps that rock the wings only 5 or 10 degrees, just sit back and let the rally level out on its own. You will find this much less tiring than chasing the controls constantly. When you are flying at a low altitude, for instance on landing approach, or when you encounter stronger turbulence that rocks the wings farther, use the rudder to level the wings. Remember, stepping on the high wing. The rudder will level the wings faster than the spoilerons and will not reduce total lift. This kind of stronger turbulence can also upset your pitch attitude. Coordinate throttle and elevator controls to come back to your original attitude and hold your cruise speed of 35 miles per hour. Never fly faster than 35 miles per hour in strong turbulence. As you correct the rally's attitude, pay close attention to airspeed and do not let it go above 35 miles per hour. In your previous study of micrometeorology, you have already learned how to predict areas of severe turbulence. These conditions should be avoided. If you do encounter severe turbulence in flight, slow down to 30 or 35 miles per hour at once. Try to keep the wings as level as possible while you leave the rough area. If you can fly out of the severe turbulence, make a precautionary landing at the nearest available site before the situation becomes an emergency. Flying safely in turbulent air is mostly a matter of experience and pilot skill. This means that the definition of severe turbulence will change from pilot to pilot, or for an individual pilot as expertise increases. A simple rule for all pilots to follow when they encounter turbulence would be, if it's not fun, it's probably not safe. Land and wait for conditions to improve. Stop the tape here and review this material thoroughly with your instructor before your first rally solo. The rally sport is the first production ultralight approved for aerobatics by the manufacturer. The rally sport is an exciting, high-performance ultralight. Treat the rally sport with respect. It is powerful and has lightning-quick reflexes. Before your first flight in the rally sport, you should obtain training from a Rotec dealer in the Rally 2B. After you are proficient in the Rally 2B, your training in the rally sport will be much easier. Training in the rally sport will follow the same sequence as the Rally 2B. When you check the airspeed indicator mounting, be sure you can read all speeds between the 20 miles per hour stall speed and the 60 mile per hour red line or never exceed speed of the rally sport. Wait for calm air before you start practicing with the sport. You cannot learn the relationship between control input and response in rough air. As you begin slow taxi practice, you will immediately notice the greater power of the sport. Throttle response is quick, and there is much more thrust. Rudder response is also faster and stronger. Practice slow taxi and S-turns just as you did with the 2B until you can control the extra power and rudder effectiveness smoothly. When you start taxiing with a tail up, use caution to keep your speed below 15 miles per hour to avoid an accidental takeoff. When you lift the tail for the first time, you will notice the sport reacts very quickly to pitch control. Be careful not to push the nose to the ground with the elevator. As you practice tail-up taxi, you may also notice the sport turning or yawing to the right as you add power. This is caused by engine torque and will be more pronounced on takeoff. Practice tail-up high-speed taxi until you are used to the right yaw tendency and can control it well. On your first takeoff, apply full power and lift the tail at about 15 miles per hour. You may need to hold a little left rudder as the tail comes up. When you reach 30 miles per hour airspeed, pull back very gently and the sport will lift off. Be ready to add a little more left rudder to counter the right turning tendency. Raise the nose gently to hold a speed of 35 miles per hour as you climb out. Level flight cruise will be similar to the Rally 2B other than the more sensitive rudder and elevator. The sport will cruise as fast as 50 miles per hour, but you will use less fuel and stay aloft longer at about 35 miles per hour. Descent in the rally sport will not require lowering the nose as far as you would in other rally designs. 35 miles per hour is still a good minimum descent speed. Due to the smaller wing, higher power, and higher weight, the rally sport has a more dramatic stall brake than the Rally 2B. With power on, the stall brake will come at 20 miles per hour, and there will be a noticeable tendency for the sport to yaw to the right as the nose drops. Be ready to add a little left rudder as the stall brakes. Use the rudder to keep the wings level and start raising the nose when your airspeed comes back up to 30 miles per hour. Reduce power to cruise setting after you return to level flight. Because the sport is an aerobatic design, it definitely will spin. Do not attempt intentional spins or any other aerobatic maneuver until you have 5 hours of aerobatic instruction in a certified aerobatic airplane and 30 hours of flight experience in the rally sport. You will find that the sport is normally difficult to provoke into a spin and requires some effort to hold in a spin. Neutralize all controls and the sport will recover automatically. If you do somehow manage to accidentally spin the sport at low altitude and cannot wait for auto recovery, decrease power and apply full rudder in the direction opposite to the direction of the spin. When the rotation stops, you will probably be nose down and accelerating rapidly. If the nose is not down already, lower the nose and add power to regain airspeed. In either case, start to raise the nose as soon as you have 30 miles per hour airspeed and reduce power after you return to level flight. Pattern entry and landing approach will be very similar to the Rally 2B, with the exception of making your approach a bit higher to allow for the sport's higher sink rate. 35 miles per hour is still a good approach speed. Landing technique is the same, but the sport will show less tendency to balloon and will drop onto the wheels at a bit higher speed. When you have practiced standard maneuvers, takeoffs, and landings for a couple of hours, you have gotten used to the bigger engine and faster controls, you will be ready to learn more advanced maneuvers. Practice these skills while you accumulate the 30 hours of flying time required before you begin aerobatic instruction. A last reminder, do not attempt to teach yourself aerobatics. Do not attempt aerobatics in the rally sport until you have had at least 5 hours of aerobatic instruction in a certified aerobatic airplane and 30 hours of flight time in the rally sport. When you've met these requirements, contact your Rotec dealer for advanced training in your rally sport. Enjoy your rally sport. Treat its extra power and control response with respect. We will be watching for you at Cloud Base. Stop the tape here and review this information with your instructor before you begin solo training with the rally sport.